Okay, so here we have another problem in volumetric analysis. And in this case we're told that we have an industrial effluent which contains carbon tetrachloride, that's CCl4, and benzoic acid. And basically a sample of that effluent, of that mixture, is taken, has a certain mass, and it's shaken with water. And the resulting aqueous solution is titrated against a known concentration of sodium hydroxide. So what basically is happening here is the effluent, which contains a mixture of these two substances, is shaken with water. What's that going to do? Well, if it's shaken with water, the benzoic acid is going to go into the water to form an aqueous solution, because this has the capacity to hydrogen bond with the water molecules in liquid water. Whereas carbon tetrachloride is an organic phase, and it doesn't have the capacity to form hydrogen bonds, it doesn't have a dipole moment, so it will form an organic layer on top of the aqueous layer. It won't mix with the water. And so this process of shaking the effluent with water is in order to simply extract all the benzoic acid that's present in the sample of the effluent to create an aqueous solution of it. Once we have the aqueous solution, we can then titrate it in the normal way with sodium hydroxide to work out how much benzoic acid is present. So what we're asked to do is to calculate the mass percent of benzoic acid in the original sample. So this is really going to be a four-step procedure. First of all, we will have to work out the number of moles of sodium hydroxide that were used in the titration. Secondly, we will then have to work out the number of moles of benzoic acid that reacted with the sodium hydroxide in the titration. Once we know that, we can then work out the mass of benzoic acid, and finally we can work out the mass percent of benzoic acid in the original sample. Okay, so to start off with, point 1 here, to work out the number of moles of sodium hydroxide used in the titration. Well, we know the volume and we know the concentration. So if we know the volume and the concentration, we can work out the number of moles of sodium hydroxide. That's simply going to be the concentration multiplied by the volume, which in this case is going to be 0.1546 moles per decimeter cubed. And then we have to multiply that by the volume, which is 10.59 centimeters cubed. But to keep all the units the same, we need to convert this to decimeters, which we do by dividing by 1000, because there are 1000 centimeters cubed per decimeter cubed. Okay, so if we multiply those two numbers together, we get the number of moles of sodium hydroxide, which is 1.637 times 10 to the minus 3 moles of sodium hydroxide. Okay, that's point 1. How then do we work out the number of moles of benzoic acid present? Well, we're told that benzoic acid has one acidic hydrogen per molecule. So the net ionic reaction that's going to be taking place here is there's going to be one acidic proton per molecule of benzoic acid, and that will react with one hydroxide ion from the sodium hydroxide to produce one molecule of water. That will be the neutralization that's taking place here. So you can see that the ratio of acid to base is 1 to 1. So the number of moles of benzoic acid that must be present is going to be the same as the number of moles of sodium hydroxide that we used in the titration. So to answer point 2 here, the number of moles of benzoic acid is going to be equal to the number of moles of sodium hydroxide. So the number of moles of benzoic acid is 1.637 times 10 to the minus 3 moles of benzoic acid. Okay, so we've answered the first 2 points. Point 3 then asks us to work out the mass of benzoic acid that must be present. Well, if we know the number of moles, it's straightforward to work out the mass, because we know that the mass is equal to the number of moles times the molar mass. In this case, we've just worked out the number of moles. That was 1.637 times 10 to the power of minus 3 moles of benzoic acid, multiplied by MR, its molecular mass, which in this case we're told is 122.1 grams per mole. Multiplying those two numbers together gives us the mass of benzoic acid present in the sample, which is 0.1999 grams of benzoic acid. Okay, that's the mass of benzoic acid that was extracted from the original sample of effluent. Okay, so we need to then work out the mass percentage of benzoic acid. In the effluent, and that will be given by the mass of benzoic acid divided by the mass of the effluent multiplied by 100%. The mass that we've just worked out is 0.1999 grams. The mass of our original sample of effluent was 0.3518 grams. We then multiply by 100% to give us our final result, which is 56.82%. Okay, so by mass, the effluent that's produced is approximately 57% benzoic acid, which means that 43% approximately is carbon tetrachloride.